Guys, welcome back to Kodai, and this is me, your friend again, back with another concept, another uh, concept to help you to program to check whether the entered or the given number is prime or not. So I have today two ways to help you to learn to check whether the number is prime or not. So guys, before getting to know the actual code for the program, let's try to understand what is prime number. Okay, what is prime number? So prime numbers, the basic concept, prime numbers will have only two factors, or it will have only two divisors. These are the two simple concept, and this is the basic logic behind the program, and this we will implement this logic in our program. So let's go and implement it in our program. So we need a variable to store the value of the entered number. That's why we use n, and another one more variable m and I. This is the first method that I am teaching you. Whichever method I am helping you, I am also actually I am also a learner, and these are the two ways. Of course, whichever you like and you feel like coding, you can select. I feel both have its own advantages. I will tell you at the end. Okay, flag, let's take flag equals to 0. Then we'll scan the, that is reading the given data, given input, percentage d since it is integer type, ampersand is so necessary in C, otherwise we will get an error. After scanning, m equals n by 2. Okay, and even before this, we need to check another condition. Prime numbers are actually always greater than 2, and prime number starts from 2, and the number 1 is neither prime nor composite number. So we need to check this condition, because the user may enter number 1 or the negative numbers. So to check that condition, we will use an if statement here. If n is less than, sorry, if n is less than 2, open brace, will print a statement saying that let's say that you have entered an invalid data. Okay, this will be shown in the search console, in the console, telling the user that you have entered invalid data, because the number that user should enter should be of greater than 2. Alright, then we will terminate the statement. Then m equals to n by 2. Why n by 2 is because the let's take an example, number 10. If we take number 10 and divide it by 2, the answer is 5. Greater than 5 cannot divide and make 10 equals to 0. That's the simple logic. So any number you divide it by 2 and check the condition. What condition we have to check? That we will put in the for for I equals to 2. Why I equals to 2? Because so that's the reason why we have taken I equals to 2, and the next condition I less than or equal to m. It will the for loop block will execute mth time and I plus plus, because it will continuously execute until we get the desired result. In open brace, if there is an if condition, if n mod of n mod of I equals to 0, open brace, flag becomes flag equals to 1, flag becomes 1, because already we have initialized flag as 0. Now if it is the number is divided and it becomes equal to 0, the flag becomes 1, then we close the brace. And let me add one more break statement, because if the number is been found at the earliest, if at the second iteration, we need not to check furthermore. So for that we are using a break statement and close it with brace. Then next one more if statement to just to print whether it is prime number or not. So the condition is, if flag is equals to 1, print we will be printing the prime, it is not a prime number. So printf and it not a prime number, prime number, and then close it. We have to terminate it inside and then semicolon. Okay, that's it. Then else open brace, printf, if flag remains to 0, then it is a prime number. And terminate the string, close the bracket, and that's it, and brace. Okay, that's it. Then this is the program. Let's run it and see. Okay, let me give the input as let's check for the number 100. There is an error. Okay, just a minute, it is explained before else. Okay guys, now I know why there was a problem. So we have, before executing the actual program to check whether it is a prime number or not, we are checking whether it is greater than or true. For that we need one more header file, that is stdlib. Okay, as include stdlib.h, then close it, and here we need to exit if the number is less than 2. If it is a negative number, or if the user has entered number 1, it should exit. For this, if we are using exit function, then we need to use the header file stdlib. Okay guys, that's it. Now we'll run it and see. Of course, now there shouldn't be any error. Okay, we'll run and see. We'll check for the same number 100. Enter a number to check whether the number is prime or not. It is not a prime number, guys. Do note, it is not a prime number. So we have entered number 100 and it is not a prime number. We'll check for the number 6471. Okay, we'll check for this number. it is not a prime number. Of course it is not a prime number. Now we'll check for the simpler number 137. Okay, we'll run this. It is a prime number. Okay guys, you got to know this is one of the methods. Now just let's dive into the second method. Of course many would find this second method so easier, but this method actually reduces the compilation work and uses less processing power. So if you are using like this sort of programs in bigger modules, do use this method to reduce the compilation work and the processing power. So let's now get into the second method and see how it works. Okay guys, the second method is so easier and simpler. I think many would find this second method might be easier. So let's just we'll be changing the statement from here, of course, and we need not to have one more variable m. We need not to have variable m, and then we'll take, instead of flag we'll take divisor. Okay, divisor will initialize divisor equals to 0, and same condition, if the entered number is less than 2, the program will exit. It will not go to loop inside the loop, etc. Okay, now we'll insert a loop statement for I equals to 1. This is different method. There we used to divide by 2, but it starts from I equals to, there was in the first method it was I equals to 2, then I should be less than or equal to, I should be less than or equal to n, and then it actually increments I plus plus, close it, open brace. Okay, if in the if statement, if n mod of I equals to 0, okay, if I mod of 1 if n mod of I, if n mod of I equals to 0, we count divisor plus plus, okay, divisor plus plus, that's it. We need not to have else statement and so on. Okay, from here we count divisor plus plus and terminate it. Now we exit from the loop. This is what the loop should do. Then we check whether it is equals prime or not. For that we use another if statement, wherein we put if divisor equals to 2. I will tell you why divisor should be equals to 2. Open brace, printf, it is a prime number, or we can use this method to print the number itself. %d is a prime number. and terminate the string, close the bracket. That's it. Okay, it is stored in variable n. Okay, then close it. Then else statement, else open brace, let's copy this, paste it down here. I is a prime number, is, let's print is not a prime number. Okay, then close the brace. That's it. This is the second method. Okay, I will have to tell you why I have used divisor equals to 2, because when the given number is divided, I already told why prime number will have only 2 divisors. So if we take number 7 should be divided by only 1 and 7. So if the divisor is if the condition is satisfied, if it is divided and condition is satisfied, divisor, if divisor equal to 2, if the given number is divided 2 times and becomes equals to 0, that is a prime number. If the given number is could be divided by 3 times or 4 times, the divisor will increase. So if divisor becomes 3, 4, or if divisor is 1, that number is not at all a prime number. If the divisor equals to 2, it is a prime number, because prime numbers will have only 2 divisors. Okay, let's straight away run this and see. Let's take another number. 1997 is a prime number. So let's run this and check whether what is the output for the program for the given number. Of course, as I said, 1997 is a prime number. Guys, to please note, 1997 is a prime number. The program worked very well. Let's check for the number 1888 is not a prime number. It is not a prime number. It should show, yeah, 1880 is not a prime number. Okay, let me check for the another one more simpler thing. Let's check for number 17. Okay, run it and see. Yeah, 17 is not a prime, is a prime number. So guys, I hope you enjoyed watching me coding this. Share the video if you have liked it and learned something new, and consider subscribing to the channel. Thank you so much for watching. Until the next video, guys, this is your friend signing off. Bye bye, see you, cheers guys.